make it 5 meter. So there should be half the change of the previous. So let's check UU. So from 846 to 871. So it has risen up 25 mm only. Earlier it was 50 mm. And after this, say, let me make it down towards the north direction. And suppose you don't want any slope, so you can turn off the slope, no slope, and just click north. So direction will become exactly north. Okay, copy current component and give a distance of 5 meter. Direction upwards, and you can check UU. So it is exactly same as the previous elbow. So one of the question is answered, I guess, for straight pipe. So you can have different slopes in different legs. Okay. Even you can start from flange and give a slope. So I have to discuss that also. There will be a typical case. I already key in slope 1:100. I want to change the line slope from, yeah, that is the next chapter, retrospective sloping. So we'll do that definitely. For now, I want to show you how you can give a slope after the flange itself. Okay, before that, do you want to see the isometric of this pipe? The one we modeled. See, fall of 0.5 degree. Actually, fall indicator is to be shown here. It's 200 is, I think it is rounding off the value. That's why it is not showing correctly. But the isometric option can show, instead of degree, it can show the ratio. We have checked the elevation. Definitely the elevation is different. 846, 97, 5 meter, everywhere 5 meter. So this cannot be the same slope. There's a difference of, so yeah, this is in degree it is rounded off, but later on we'll see the ISO where it shows an fall indicator of numerator and denominator. 1:2 that case, right? Anyways, what I was talking about is how you can give a slope after nozzle, even that is not the nozzle but the flange. So this is M2. Let me check QP1 both. 450. Isn't it too much? What about this? Okay, let's start a pipe from here. I'm not giving any name, just quickly hit apply. sorry, I forgot to give, say 1:100 slope this pipe. Yes, click to connect, right? Now I want to give a slope right after the flange. Earlier it was not possible. You used to give using zero radius bends, but now it is possible. Let me select the flange, deselect, make it well neck. Okay. Then if you want to give a slope after this, as of now, there's no slope. So go to modify, same thing, slope down and select the direction. Select north. So it brings the slope, right? So if you create an elbow, connect it down and give some spool piece, you can see this comes in slope, right? And what is the situation here? You can see it creates a trim at this point. So exactly this will be filled with maybe weld at site. Some gap is created. So this is how it accommodates the slope. So this was not possible earlier, right? We were creating through zero radius bends. Okay. Now let's discuss retrospective sloping. Now what is retrospective sloping? Uh, so if the slope reference have been applied, slope can be applied to an orthogonally rooted pipe respectively via the slope editor form. So this is there in this button is there. Let me show you few points. So in this retrospective sloping, you can slope leg wise, means individual legs can have different slope, or you can specify one slope for full complete pipe, right? And slope can be means slope can be made forward or slope can be made backward. Means where to start slope from the starting point or from the backward, and then uh, define the slope. In this, there is a special thing called anchors. For example, in this pipe, I want to fix. So when the slope starts from this elbow, this goes down. This pipe goes down. But I want to fix some anchor point in between. For example, there is a shoe in between. For that, elevation will not be changed. So how should it adjust? It should, let me annotate. For example, I have placed a shoe at the bottom. Normally, how it will go? Normally, it will slope downwards like this. But in this case, if there is a shoe, it will move this point up by adjusting this height. So in case of anchor, it normally goes like this. If there is no anchor point, it will simply go and slope like this. Means, let's talk about here actually. This is the elbow. So this anchor point can be any component or can be any position on pipe. Remember, start and ends are always anchor. So we are not changing start and end. And any point in between the pipe can